Hi, my name is Jonathan Schmidgall, and I'm really excited to have the opportunity to present to the TESOL ITA interest section. A little bit about me before I jump into my presentation. I'm a research scientist at ETS in the Center for Language Education and Assessment. I think many people associate ETS with the TOEFL, but we do a wide variety of research related to language assessment, teaching, and learning, generally focused on the use of English in academic and workplace settings. At ETS, my research tends to focus on the issue of validity and validation in language assessment. But throughout my graduate education, I worked very closely with ITA assessment and developed a really strong interest in the complex issues related to teaching, learning, and assessment in this field. Fundamentally, to me, that involves the issue of how to accurately and appropriately define and measure ITA's oral proficiency and how to more symbiotically align ITA language learning and teaching with assessment. But for the purpose of today's talk, I'm going to largely overlook these more foundational, fundamental issues to focus on a highly practical one, evaluating the outcomes of ITA assessments. So I'd like to focus on this question in my talk. How accurate is our decision-making? So to elaborate, we utilize an evaluation of ITA's language proficiency, whether it's a large-scale assessment we're using for screening purposes like the TOEFL IBT, or a local ITA assessment, such as UCLA's Test of Oral Proficiency, or TOP. Based on test scores, we apply rules to make decisions, such as pass, conditional pass, or non-pass, and there are immediate consequences that follow based on the decision. And while I would argue it's important ultimately to consider all of these issues in greater detail, such as the quality of our evaluation, how we're measuring proficiency, and the measurement characteristics of our evaluation, reliability, validity, moving on to how we set up these decision-making rules and categories, including where we set the cut scores. And ultimately, the policies that we put in place to address what happens when incorrect decisions are made. But again, in this presentation, I'd like to focus on ways that we can quantify the effectiveness of the system that we've set up, or the likelihood that we're making correct decisions given all of these elements. So this starts with a focus on decision error, which involves setting up a simple table. On the one hand, we have the actual decision we've made based on our assessment and our decision-making rules. I'll be using an example throughout of an ITA test that involves 3 decision categories based on a test score. Those categories include pass, conditional pass, and non-pass. This is similar, I think, to many the policies that many ITA programs have in place. Some might have multiple conditional pass categories, but for the purpose today, I'll just focus on this general example. To set up this table, we also need to separately consider the ideal or true decision, independent of our assessment. Does the ITA candidate truly have the minimum level of proficiency that's required or implied by the pass and conditional pass decision categories? So we finished setting up this table by considering the implication of each combination of actual decision and true decision. If our actual decision corresponds to the ideal decision, then the actual decision is true. We've made decisions that are accurate, that reflect ITA's true abilities. But no decision-making system is perfect. If a candidate receives a pass, but should truly receive a conditional pass or a non-pass, we would consider those false positive decision errors. The same logic applies to the actual decision of conditional pass. If a candidate should have received a non-pass, it's a false positive decision error. We can't have false positives for the non-pass category because this category can't possibly overestimate an ITA's proficiency. If we underestimate a candidate's ability, true ability, we have false negative decision errors. In other words, the actual decision is a lower decision category than it should be. So for example, when we assign conditional pass, when the decision should be pass, or non-pass, when the decision should be conditional pass, we have false negative decision errors. So you might ask, why go to the trouble of setting up a table like this? You might have, some of you might be familiar with this kind of table. It goes by different names, a contingency table, for example. Well, there's a few reasons why you want to do this, I believe. First and foremost, it forces us to think systematically about the ways in which decisions about ITA certification can potentially go wrong, and hopefully how we can have policies in place to address these if and when they arise. So in considering these issues and appropriate policies, we might decide that certain types of errors are relatively more concerning. So you might think any type of decision error is concerning, and while that might be true, some types of decision error might have a more substantial negative impact, or they might be difficult to correct. For example, if a student receives a pass and they should have received a non-pass, that type of error can be difficult to correct once an ITA is in the classroom. If an ITA should have received a conditional pass and they received a pass, this is also a false positive decision error, but it might not be as severe a concern, as policies could be put in place to provide ITAs with additional training or support without having to remove them from consideration as TAs, or in the worst case, from a classroom, which would be very disruptive. So a second reason why I think you'd want to focus on creating a table like this is it sets you up to evaluate the likelihood of different types of decision errors. And hopefully you've already considered, whether you're more concerned about one type of decision error for a specific category versus another. And being able to evaluate the likelihood of different types of decision errors gives you a better understanding of the accuracy of your decision-making system, and can help identify areas where we either need to improve it or have policies in place that can mitigate the impact of decision errors that are more likely to occur. So I'm going to focus in this talk on two general approaches for estimating the likelihood of these different types of decision errors. So in the first approach, we're going to focus on the issue of measurement error. So I'm sure that many of you are familiar with the concept of reliability, or the to which test scores are consistent or approximate a true score. So in ITA assessment, we typically focus on interrater reliability, or the consistency of scores across raters. It shouldn't matter what rater evaluated, which rater evaluates the test taker, the score should be the same. So let's assume we have an estimate of interrater reliability. How does reliability estimate or impact decision accuracy, which is what we're really bottom line concerned about? For example, the reliability of the TOEFL IBT speaking section has been estimated to be 0.86. And the reliability of UCLA's test of oral proficiency has been estimated at 0.91 to 0.93. This estimate can vary slightly. It's what we call sample-based. It's based on a particular data set. Usually that's a year's worth of test takers and ratings. So it might vary a little bit, but ideally you want to see minimal variation, and that's what I've heard based on analysis of data. So given these estimates, we often use rules of thumb to interpret them. And based on these rules of thumb, for example, we might want to see a minimum of 0.7. We might think 0.8, is reasonable. 0.9 is great. So looking at these estimates, we might look at them and think, we're reassured. It's reassuring. We have a solid to strong level of reliability. But ultimately, as I've argued, what we care about is the accuracy of our decisions. So how does reliability impact decision error? Well, there are different statistical approaches we can use, but I think the most straightforward thing to consider is the standard error of measurements, typically abbreviated as SEM. So the SEM is an easily interpretable index of reliability and indicates the precision of a test in terms of the actual score scale. There are different ways to estimate SEM, but the simplest way just requires two things. It requires a good estimate of reliability, and it requires the standard deviation of test scores, which is very easily calculated if you just have a data set of the test scores. For example, the SEM of TOEFL IBT speaking is 1.57 on a score scale of 0 to 30. And the SEM of UCLA's test of oral proficiency is around 0.3. Again, this can somewhat vary a little bit depending on your data sets, but it's around 0.3. And you really need to know what the score scale is to be able to interpret the SEM. So the UCLA TOP score scale runs from 2.5 to 10. Why do you want the SEM? Well, you can use the SEM to estimate confidence intervals for test scores. This can give you a general sense of where you're likely to see decision errors, and this is pretty easy to do. You can also use the SEM to estimate the likelihood of different types of decision errors. And I've given it an asterisk here because this is a bit more technical, so I won't be going into all of the details, but I'll show you what you can get out of this type of analysis. So let's assume we have the SEM. How do we get to decision error? So as I just said, I'll be showing you two approaches. First, you can estimate a 95% confidence interval near the cut scores using the SEM. And second, you can do a more technical analysis to estimate decision error using the SEM and a data set of test taker scores or the score distribution. So if this all sounds like jargon to you, I'll unpack it and explain it with an example. So a confidence interval for a score is basically the interval of the most believable true value, taking into account measurement error. So I'll illustrate what this means using the test of oral proficiency. So what I'm about to go through is described in much more detail in a paper, but the paper is a bit technical, so this is just a brief summary. So the TOP score scale, again, goes from 2.5 to 10, but I'll focus just on the upper part of the scale, 5 to 10. All scores are reported to 1 decimal place. The cut score for a conditional pass decision is 6.4. So any lower score results in a non-pass decision. The cut score for pass is 7.1. So 7.1 and above results in a pass decision. For the TOP, the SEM is around 0.3, as I said, so we'll use 0.31. The 95% confidence interval for a score is 1.96 SEMs in each direction. I won't go into the details of why it's 1.96, but it's based on a statistical assumption. In any case, using this information, using the SEM, which you can estimate very easily based on if you have the reliability and standard deviation of test scores, using the SEM, you can construct a confidence interval by just multiplying it by 1.96 and adding that SEM basically doubled to your score that you're focused on in each direction. So for example, the 95% confidence interval for the score 7.1, the lowest passing score, includes the range 6.5 to 7.6. So you can see the range there. So with a 95% degree of confidence based on our statistical assumptions and the information we have about reliability or the precision of the test, we can say with 95% confidence that the test taker's true score, the test taker who won their true score is in this range from 6.5 to 7.6. So what this tells us is that based on measurement error, based on what we know, what we've estimated about the measurement error of the test, we can say with 95% confidence that a score of 7.1 is distinct from scores outside that range. Scores inside that range are not distinct from a measurement perspective. So if you receive a score of 7.1, we could reasonably expect you to score within this range if you retook the test and your ability hadn't changed. Note that we're using a 95% confidence interval. If you are satisfied with a 66% confidence interval, that is basically one SEM in each direction. But the standard practice is more to use a 95% confidence interval here. So by merely using information about, before we go on, I'll just note that a test taker who scores 7.1, fixating on this example, would receive a pass decision. It's the lowest possible score for which you would get a pass decision. But we could also expect them to score a 7.0, a 6.9, a 6.8, all the way down to 6.5. And if they scored in this range, we would assign them a conditional pass decision. So if a test taker receives a 7.1, but their true ability is actually in this conditional pass range, then we would be making a false positive decision error for that test taker. It's not possible to have a false negative decision error for this score of 7.1 because there's no higher decision category to assign. So merely by using this information about the SEM, we can have a high degree of confidence that a test taker who receives a pass decision would not receive a fail decision if they retook the test, had a different rater. We're in a different mood. But we can't really say much about the adjacent decision category, conditional pass. So if you're able to do a much more detailed analysis using the SEM and score distribution, you can get more specific estimates of the likelihood of types of decision errors. So I'll unfortunately need to skip over the methodological details, but for the TOP, test of oral proficiency, I found that certain types of decision errors were extremely unlikely. If you received a pass score, the likelihood of it being a false positive for a non-pass score was less than 1%. And so this is consistent with what we might expect based on what I just showed you for the confidence interval for the lowest passing score of 7.1. What about other types of decision errors for pass scores? Conditional pass. Well, this analysis showed that conditional pass false negatives were also still pretty low, around 5%. And you might think this is surprisingly low, given what we saw, what we observed about this confidence interval. But this analysis also takes into consideration the actual distribution of test taker scores. And in reality, the test takers in the pass category had relatively high scores. There weren't that many test takers with a 7.1 or a 7.2, at least in the data sets that were included in this study. And so that influences these estimates of the likelihood of false positives and false negatives, because it provides these estimates based on actual data and what you're observing and your test taker population. If there were a lot more test takers who received passing scores closer to the cut score, then this decision error for the conditional pass category would be much higher. So to summarize, the true classification rates were quite high, and arguably the most concerning types of false classifications were quite low. So what do we do with this knowledge? Well, first, it's reassuring, I think, to know that we can have a lot of confidence that we can meaningfully differentiate pass and non-pass decisions thanks to the reliability of test scores and the distance between the cut scores. If the cut scores are much closer, we might see this non-pass decision error, false positive or false negative increase. Second, we know that decision errors are somewhat likely for the adjacent categories. And so we can design policies with this information and any other local concerns that we have in mind. For example, a department with extremely high standards may want to have confidence that anyone assigned a pass rating should not actually be in the conditional pass category. In this case, raising the cut score for pass would decrease the likelihood of this type of decision error. So to summarize, this approach helps you use information about reliability in a much more practical way by quantifying the likelihood of different types of decision errors based on the measurement precision of a test. So I provided one example using an ITA test, the TOP, but this general approach can be used for screeners. And assuming that you've mapped the screener to your ITA test, and influence the recommendations that ETS has made about the use of TOEFL IBT speaking test scores for ITA screening. However, I'll caution that the approach is slightly more complicated for screeners, as she details in a 2007 paper. First, it's influenced by the comparability between an ITA test and the screener. They need to measure a similar ability. And you should, in general, it's good to be skeptical that a high stakes or a large scale assessment designed for a general purpose measures the same ability that you're trying to target in your ITA assessment. It's good to start from a point of skepticism. This is an issue that we discussed in a recent publication on the use of TOEFL IBT scores for selecting ITAs. Secondly, this approach is also influenced by the reliability of the local ITA test. If decision errors are already a problem, then there'll be a problem for the screener too. So now let's move on and look at a second complementary approach to looking at decision error, that criterion measure perspective. So in this approach, classification decisions based on the test are compared with classification decisions based on another measure, the criterion. In this approach, the criterion evaluation is treated as the ideal evaluation, and then you estimate decision error based on this comparison. So when you think about what makes a good criterion, there are many possibilities that exist. We provide some recommendations in our recent publication on the use of TOEFL for IBT screening, but the challenge is identifying a criterion that facilitates an independent evaluation for all potential decision categories. For example, if your criterion is some kind of TA evaluation obtained during or after a semester of teaching, that can be a useful criterion in some ways, but the challenge with that criterion is you're restricting your focus to ITAs who have been authorized to teach. And you won't be able to evaluate how your non-pass decision categories are functioning because you don't have any data on how they're performing in the actual classroom. So I'll provide an example of an approach that meets this particular challenge, I believe, using undergraduate perceptions as a criterion. So why use undergraduates as a criterion? Well, simply put, undergraduate perceptions matter. ITAs should be comprehensible to the local undergraduate population at large. And this is really the motivation behind ITA testing and training. On the other hand, research has shown that undergraduates' perceptions of ITA speech may be influenced by factors beyond oral proficiency, such as ITA's teaching skills, and undergraduates' own experiences and attitudes towards ITAs. So we really need to keep this in mind when collecting and interpreting this data and using it as a criterion. I'll show you an example of how this was done, again, focusing on the test of oral proficiency. And so the research question was this: to what extent do undergraduates' perceptions of ITA candidates correspond to TOP-based classifications? So I looked at this in three slightly different ways. First, two major ways. First, for a sample of undergraduate students trained to interact with ITAs during ITA testing. So undergraduates' perceptions were obtained in this context, in a context where the actual undergraduate is, interacting with the actual test taker. And in the second example, we'll look at undergraduate perceptions where they're not trained to interact with ITAs in a testing context, and they're simply viewing a video of ITA's test performance and answering some impressionistic questions about the ITA's oral proficiency. So in both samples, undergraduates recruited from a wide variety of departments across campus. And in both samples, undergraduates evaluated ITA's oral proficiency using impressionistic items, Likert type items, where they rated the ITA's comprehensibility and communicative effectiveness and perceived adequacy as an ITA. I should note that these were two different studies, and I'll be omitting a lot of detail, but I'd be happy to answer any questions about them. So I'm going to present the results of each study using a chart instead of the decision table we used earlier. I think it's a lot easier to process visually. So the first sample of undergraduates, as I said, interacted with ITAs during their oral proficiency test. And then the undergraduates provided their evaluations afterwards. These evaluations were provided for research purposes and did not influence ITA's test scores, which were based on the evaluations of trained raters. So here were the results. So on the horizontal axes, there are the three TOP decision categories: the evaluation based on TOP scores, non-pass, conditional pass, and pass. On the vertical axes, you can see the percentage of undergraduates who evaluated the ITA candidates on their acceptability as a TA based on the ITA's perceived oral proficiency. So for example, among all the ITA candidates who received a TOP score that corresponded to pass, the far right bar, about 88% were also rated acceptable as an ITA, or yes, the green portion of the bar. 11% in the pass category were rated unsure by the undergraduates as to whether they had the oral skills necessary to TA, the yellow portion of the bar. And about 1% were rated as not acceptable as an ITA or no, the red or orange portion of the bar. So ideally, we would like the pass category to be all green, provisional pass to be all, and non-pass to be all red, or at the very least, we'd like to see no red for the pass category and no green for the non-pass category. Overall, there seems to be very little decision error for the pass category, slightly more for the non-pass category, two different types of, there's false negatives and false positives. And the provisional pass category, or sorry, slightly more for the non-pass category, there's two different types of false negatives. The conditional pass category, it's a bit messier as we might expect. Interestingly, if we further restrict this sample and only look at the data where multiple undergraduates rated the same ITA and agreed on their rating, we get slightly different results. So what we're trying to do, in essence, is increase the reliability of our undergraduate ratings. So if we apply this more stringent requirement, the more concerning types of decision errors are minimized. There's no green in the non-pass category and no red in the pass category. And for the non-pass category, our main concern is false negatives for provisional pass or conditional pass, which is the yellow portion. So what would this figure look like for a different sample of undergraduates? Undergraduates who did not interact with ITAs directly, but observe a video of their test performance and then provide an evaluation. Well, it looks a bit different. First, you can see there's a lot more uncertainty indicated by the yellow portions. It also suggests that there's more decision error associated with the pass and the non-pass categories. For ITAs who received a TOP score corresponding to pass, about 8% of the undergraduates in this sample believed they did not have the oral skills necessary to TA, and about 25% were unsure. On the other end, for ITAs who received a TOP score corresponding to non-pass, the far left, about 20% of undergraduates believe they could communicate as TAs, the green. 50%, the yellow, were unsure. So one detail I should note, in this study, undergraduates did not directly respond saying yes, no, or unsure. They responded to a Likert type item that was labeled strong yes at one end and strong no at the end. So this approach likely inflated responses in the middle category as compared to the first study, the unsure category. But even if we focus on the extreme categories, yes and no, this sample suggests a higher rate of false negative decision errors for the non-pass category, at least 20%. This is the green portion of the non-pass bar, and a higher rate of false positive decision errors for the pass category, at least 8%. And that's the orange or red portion of the pass far right bar. So I'd like to conclude this example by highlighting a few key points. First, as ITA's intended interactants, undergraduates' perceptions matter. And I'd suggest their perceptions are an important criterion to consider. But along with that, analyses that use their perceptions need to be carefully interpreted. I've just shown you figures that suggest 3 slightly different evaluations of the effectiveness of ITA test decisions. But I believe the differences can largely be explained by a few key points. First is the way we obtain undergraduates' judgments and how it can impact results. So in study 1, undergraduates engaged with ITAs in person, while in study 2, they observed a video sample of ITA speech. It's important to consider in trying to design a study like this. What is the real world interactional norm, and to what extent can that be replicated in the study? Second, undergraduates' judgments, our research has shown that they're highly impressionistic. Now, I mean, part of the issue is we are using an impressionistic measure to collect their impressions. But I would argue once we train them to make evaluations, then the kind of evaluations we get are not necessarily going to be the kind of judgments that undergraduates are more naturally likely to make in the real world. And what we're trying to do is get at those natural impressionistic decisions and to have the information collected in our study approximate those types of judgments that they make in the real world to the greatest extent possible. So these judgments, I would argue, are highly impressionistic and typically reflect factors beyond an ITA's language proficiency. So you can reduce some of this idiosyncrasy by pooling undergraduates' judgments, like we did in that second portion of the first study, taking averages or focusing on consensus trying to increase the reliability. As you, again, as I showed you in the second chart, but it also might be useful to preserve the idiosyncrasy of individual undergraduate perceptions. It kind of really depends how you want to present this information and what your goals are. So conducting this type of evaluation can give you a better understanding of the likelihood of different types of decision errors, which can inform ITA assessment policies. But as we know, undergraduates have a role to play in this interaction. Depending on what we learn from this type of analysis, it may point to the need to better orient undergraduates towards the opportunities that interaction with ITAs presents. Given the role of English as a lingua franca in everyday academic and professional contexts, you know, our campuses are diverse places where people generally use English to interact, but may come from a variety of linguistic and cultural backgrounds. And this is true for the workplace as well. So I'll close with a brief summary. First, I've argued that analysis of decision error can help us evaluate the effectiveness of our decision-making system by identifying which types of decision errors are more likely to occur, false positives, false negatives, and for which specific decision categories. And when we understand where decision errors are likely to occur, we can design policies that minimize their negative impact. For example, dealing with unacceptably high false positive or false negative rates may require lowering or raising the cut score, revisiting the design or scoring of an assessment, or even adding an additional evaluation into the decision-making procedure. I know many ITA assessment programs already have these remediation procedures in place, but this evaluation can let you know how you're doing and if you're allocating resources properly. You can also approach this evaluation from a measurement error perspective or a criterion measure perspective, ideally both, as they give you different information. Thanks for listening. So I'll just add that I'm always happy to communicate with ITA professionals. Please feel free to reach out to me over email. And I'll close with this list of publications I've drawn on throughout the presentation. I've also highlighted this recent ETS publication, which I authored using TOEFL IBT test scores for selecting international teaching assistants. It covers some of these issues very briefly and succinctly, but it also addresses some of the more fundamental issues I alluded to during my initial introduction. How we define and measure ITA oral proficiency, and the relevance of the TOEFL IBT in this context. Thanks. I look forward to our Q&A session.